In this video, I'm going to talk about the recent meteorite strike in New Jersey, along with others that happened in British Columbia and Alabama. We're also going to discuss the peak scale meteor, the Getafe rock, and what it has to do with sea urchins. I'll also get into the constellation of Fucus and two objects that can be found there. Those are the nebula that's left over from Kepler's star, and the most recent research on the exoplanet Gliese 1214b. I'm Cameron, and this is my channel. Welcome to the Sexy Universe.
All the stars in the sky, all the lights on the highway, oh, they keep us coming alive.
Hey everyone. I proved myself wrong this morning and wound up in a rabbit hole. And if you stay around, I'll tell you about it. So the police in Hopewell Township, New Jersey are saying that it looks like a meteor went through someone's roof. I couldn't find any pictures of the roof, but here's where it dented the floor. There's a close-up of the melted side of the meteor. And when they flipped it over, you've got this side that looks like it broke off. And I thought to myself that if this thing was flying into your house, there's no way your house would remain afterward. And my main thought was that this meteorite would be going so fast that it would just have to destroy the whole roof and everything and set the house on fire. Of course, that doesn't usually happen, so I had to think about why. Gravity pulls on everything the same. So if you took an elephant, it would have the same density as a baby dragon, right? But if you were to drop an elephant off of like the Empire State Building, it would be everywhere, while the baby dragon would probably hit the ground and be okay. The elephant would actually be going faster than when it hit the ground than the baby dragon would. And the reason is because the elephant, even though it's bigger and it has more surface area, it actually has less surface area for how big it is. Just like if I take this piece of cheese and cut it in half, even though each side has half the amount of cheese, it actually has more surface area because I've added a whole other side to it. Which brings me back to this picture of the meteor. It was probably off a bigger object that was going through the sky, and this piece broke off, which means there should be other pieces. And because of how small it is, it was probably only going 100 or 200 miles an hour when it hit. And just like if your car hit something at 100 miles an hour, it wouldn't explode into nothing, neither would this. Back in 2021, there was a lady in British Columbia who was sleeping, and this meteorite landed on the pillow next to her. And this is where it came through the ceiling. Back in 1954, this lady in Alabama, Ann Hodges, was taking a nap when a meteor came through the ceiling. The meteor bounced off the floor and the wall, hit the radio, and then it hit her. And that was the aftermath. But that's actually the only well-documented incident of a meteorite actually hitting a person. Incidentally, Ann Hodges was sued by her landlord to get possession of the meteorite, and she wound up having to give the landlord $500 for it. Thanks for listening. More about meteorites. Specifically, what does this meteorite have to do with this sea urchin? This here is a video of the Peekskill meteor. The Peekskill meteor came through in 1992, October 9th, and it's the most studied meteor in human history. At least 16 home videos about it were collected. It was first noticed over Kentucky where it broke apart, and it streaked across Pennsylvania with the last piece landing in Peekskill, New York. The total trip, if I'm correct, was something like 33 seconds. I looked up some of the data on where this meteor came from. This purple is the orbit of Jupiter. Red is the orbit of Mars. The bluish green is the orbit of Earth. This green, these little green dots represent the asteroid belt that's just outside of the orbit of Mars. And this brown is actually the orbit of that meteor. So you can see it crosses Earth's orbit, and that's how it wound up in our atmosphere. These two little asteroid groups in Jupiter's orbit are called the Trojans and the Greeks, which I don't really get because the Trojans were Greeks. When the meteor hit, it smashed into this 1980 red Chevy Malibu. Shout out to Chevy, but it couldn't hold up to a meteor strike. It went right through the trunk of the car. I assume insurance paid for all of it, but then again, you never know. Anyway, that Peekskill meteor car is actually pretty famous, and you can go see it at the museum if you want. Well, a couple years later, in 1994, this guy, Jose Martin, was driving his Beamer in Spain, in the town around the town of Getafe, and you can see something went through the windshield there. What came through the window was this, and it smacked the steering wheel, deflected back into the dashboard, and then bounced into the back seat, missing both the driver and the passenger. And for 5 years, everyone thought it was a meteorite. Well, it was analyzed, and the level of carbon-14 in it matched Earth's atmospheric level of carbon-14 after the 1950s. So before the 1950s, there was less radioactive carbon-14 in the atmosphere. And the reason is because back in the 50s, there was a lot of this going on, nuclear tests. So the rock just couldn't have been old enough to be a meteorite. Which brings me back to the sea urchin. The same method was used to analyze sea urchin shells, and it was found they could live as much as 200 years. Thanks for listening. Ophiuchus, the serpent bearer. I feel like I've seen him walking around the locker room before. It's actually pretty close to the equator. There it is, right? And actually, its legs kind of extend down to here. Here is the Milky Way. If you look close right here, you can see the teapot of Sagittarius, and his arrow points toward Antares, which is the heart of Scorpio. So here's my tracing and drawing of all that to make it a little more obvious. This line here is the plane of the ecliptic, so that's actually where the sun goes through. So if you're a Scorpio, there's actually a good chance you're actually an Ophiuchus. Gives you an excuse to do a lot of things. And here's the teapot of Sagittarius. This is actually a bow, and it points to Antares, which is the red star in Scorpio. In 1604, there was a very bright star that appeared in the foot of Ophiuchus. It was so bright you could even see it during the day for about 3 weeks. And at night, it was 2.5 times as bright as every other star in the sky. That object, which came to be known as Kepler's star, was actually a Type 1a supernova. In order to create a Type 1a supernova, first you need a white dwarf. White dwarfs are what's left over when a star like our Sun uses up its hydrogen and then its helium in fusion, and it all kind of compresses down, and what you have left is this hunk that's made up of carbon, nitrogen, and oxygen, and some magnesium. But it's all crushed together like a diamond. A diamond is made almost exclusively of carbon, and here's how you draw it. You start with a C. Carbon makes 4 bonds, and it bonds to other carbons. And you can keep using the down lines to keep the whole thing going. Sometimes other things break in. For example, a whole bunch of carbons will make a black spot, nitrogen turns a diamond yellow, and boron turns it blue. A white dwarf is the same way, except it's mostly going to be carbon, nitrogen, and oxygen. And you can just keep drawing out the structure. These are all so compressed that the electrons run around freely, so it's more like a metal. The Type 1a supernova happens when a white dwarf steals enough material from a companion star that it all just explodes and the whole thing goes at once. And when it goes, the only thing left behind is a nebula, like this. In fact, specifically that. Looking at the star map, here's the Milky Way, here's the galactic center, and if we go over to the side, we get back to Ophiuchus. And if we zoom in on that, we get to this little red dwarf star right here, Gillespie 1214. It's 47 light years away. And it has a planet. The diameter of that red dwarf is about a fifth the radius of the sun. So it would be about as big as the top of this bulb compared to this basketball. So there's the red dwarf, and here's the planet that goes around it. That planet, its radius is 1/8 the size of the star. I don't have enough space to show how far apart they are, but they're actually so close that this planet whips around it once every day and a half, so every 36 hours. It's hard to describe this object because we don't have one like it in our solar system. But the best way might be to say it's like an average of Earth and Neptune. So it's about a third the size of Neptune, but it has half its weight. So if you've ever picked up Neptune, and if you cut that in half, then you know how heavy this planet is. Ever since 2009, astronomers with NASA and the European Space Agency have been studying the atmosphere of this planet, even though it's that far distant, using Hubble and the James Webb Telescope to try to figure out what that atmosphere is made out of. And what they've repeatedly found is that it's mostly made out of water. But what kind of water? What phase of water? There's a lot of different things that water can be. For example, talking about Neptune again, the ice on Neptune is so cold that it bunches together close enough to act like a metal. So electricity actually can go from one end of the planet to the other in just a matter of seconds. So there's been a lot of conjecture about what this planet would actually look like. Would it look like this? Or this? Or like this? Or does it look like that? Well, according to our newest observations, the atmosphere is almost entirely made out of steam. Very hot, high-pressure steam with steam plasma on the top. And since that plasma is ionized, it would look a lot like lightning. Well, steam is still water, so I think the basic color would be like this. And then we just add red light and lightning. Thanks for watching. Please click the like button and put your thoughts and comments in the comments section below because it helps with the YouTube algorithm. Don't forget to hit that subscribe button, and we'll see you next time on The Sexy Universe.
All the stars in